Good evening. Good evening. So today, first I discuss rank correlation coefficient. Yes, Shashwato, good evening. So please tell your friend to join. Okay. I see 7 of you watching now. Please tell others to join. Dr. Prabhu, good evening. So can I start? Dr. Prabhu Shashwato? Okay. Good evening, Swarnabhu. Are you hear me properly? Am I audible? Please tell me fast. Okay, thank you. Thank you. Oh, Shashwati, yes, but after uh, first half I discuss rank correlation coefficient, then we start our quiz. Okay. Yes, Manusha, thank you. Thank you, Pritam. For calculating, we know for calculating the product moment correlation coefficient, it is essential that measurements on the two characters okay, Pritam, thank you for your suggestion. It is essential that measurements on the two characters are available. But in many cases, the characters may not be measurable or even if measurable may not be measured for limitations of cost or time or for lack of appropriate measuring instrument. Sometimes, although measurements may be available, making it possible to calculate the product movement correlation a rough and ready substitute may still be called or to reduce reduce the arithmetic work involved. It may possible it may be possible to use a rank correlation rank correlation coefficient in all these situations. Suppose that it is possible to arrange the individual according to the degree to which they pose character under inquiry. Although the character may not be directly measurable, thus, for example, a number of operators may be arranged in order of efficiency by their supervisor, although it may not be easy to offer any numerical measure of efficiency. Such an order arrangement will be called rank. And the ordinal number indicating the position of a given individual in the ranking is called fixed rank. A ranking where two or more individuals are allotted the same rank is called a tie. To be specific, rank R means that the rank that with respect to the character under inquiry R minus 1 individuals have the character in a higher degree than the individual getting the rank R. When there are two series of ranks or the same set of individuals corresponding to two different characters or two judges assigning ranks for the same character. One may be interested to know if the two series are associated. The association between two series of ranks for the same set of individuals is called rank correlation. There are two principal coefficients of rank correlation, namely Spearman's rho and Kendall tau. Kendall's tau. Here today I discuss Spearman rho. Okay. Spearman rho. Case 1, no tie. That is there exists there no ties occur. Okay, so assuming case there are no ties, suppose we have n individuals and their ranks in the two series are U1, U2, UN, and this is for judge 1, and for judge 2 these are V1, V2, VN. Okay, these ranks for judge 1 for the n individuals, and for the same n individuals judge 2 gives the rank V1, V2, VN. When there are no ties, US and VS are some permutation of first n natural number. Are you agree? Please tell me. Uh, you understand this statement? If there are no ties, ui's and vi's are some permutation of first n natural number. If not, please tell me. I will explain it. Please tell me this statement. Okay, I will explain. Suppose you have 5 individual. I denote this 5 individual A1, A2, A3, A4, A5. Okay, and judge one say I choose 2 judges. Okay, Shashwat, I explain. Suppose you have a 5 individuals. I denote A1, A2, A3, A4, A5. Okay, Shashwat, I choose 1 judge. Shashwat, and Shashwat give the rank of this A1, A2, A3, A4, A5 as suppose 1, 3, 5, 2, 4. Okay, all right. Shashwat give the rank of this 5 individual as follows. So if you look at this, wait. Fine. So okay, fine. So if you look at okay, thank you. So Shashwat give these individuals 5 individuals this rank. That means A1 receive 3 rank 3, A2 rank 1, A3 rank 5, A4 rank 2, A5 rank 4. This means if you look at this number 3, 1, 5, 2, this is nothing but a permutation of 1, 2, 3, 4, 5, one permutation. Similarly, Pritam, if there is no tie, I consider Pritam is another judge. Then Pritam provide the give this rank as follows: 2, 3, 4, 1, 5. This is also the permutation of first 5 natural number 1, 2, 3, 4, 5. So if there is no tie, this means the rank of these 2 judges are nothing but a permutation of first n natural numbers. Agree? Agree? শাশ্বত, are you hear me? Please tell me, agree or not? Pritam, Arko Prabhu, Ornisha, please tell me. Okay, thank you. So let di, which is the difference between rank of, okay, thank you, rank of two judges for ith individuals, okay, because ui is the rank of ith individual given by judge, first judge. Similarly, vi is the rank of ith individual given by second judge, and I denote this di, which is the difference between ui minus vi. Okay, so I should be 1 to small n. Then Spearman rank correlation coefficient denoted by small r in suffix capital R is given by one minus 6 into I from 1 to n di square divided by n into n square minus 1. When there is perfect agreement between the two series, between two series or two judges, association is said to be positively perfect and hence di equal to 0 for all I. This means summation di square 1 to n equal to 0. This means r in suffix capital R, this should be 1. So, again, when there is perfect disagreement between the two series, association is said to said to be negatively perfect. And in that case, Vi should be n minus ui, just reverse. That means if Shashwato gives rank 3 for A1 individual, then Pritam should give, that is 5 minus 3, 2. Okay. When Shashwato for rank 1, then Pritam should give 5 minus 1, that is 4, and so on. Okay. Then, sorry, n minus vi plus 1. Okay. So this should be Shashwato give 3, then should be 5 minus 3 plus 1, that is 3, and for 1 this is 5 minus 1 plus 1, so it should be 5 minus 1 plus 1, that should be 5. Okay, so this is the procedure. So for each other, and hence summation di square I from 1 to n, this should be I from 1 to n di square, this is equal to, sorry, I from 1 to n di square means n minus ui plus 1 whole square, and this should be, to simplify this, we get four into so I think it should be, sorry, it should be di means ui minus vi, then it should be 2 ui minus n minus 1 whole square. So now this is 4 ui square minus 4n plus 1 summation ui plus n into n plus 1 whole square. Okay, so summation ui square is nothing but a sum of square of the sum of the natural number. Okay, sum of the square of natural number. So this is nothing but this, and this should be 1 plus 2 plus up to n, and it is n into n plus 1 whole square, and we know this equal to n into n plus 1 to n plus 1 by 6 minus 4 into n plus 1 into n into n plus 1 by 2, and this is n into n plus 1 whole square. After simplification we get 1/3 n into n square minus 1, this change, and then small r suffix capital R equal to 1 minus 6n n square minus 1 by 3 into 1 into 1 by n into n square minus 1. So this is nothing but a 1 minus 2, which is minus 1. So we see that if for perfect positive agreement, the Spearman rank correlation should be 1, and for perfect negative association it should be minus 1. So now the next problem is how to derive this formula. Okay, how can I get this formula? So now we consider the product moment correlation coefficient, that is consider product moment correlation coefficient between UI and VI. Then U bar, which is equal to 1 by n, sum over UI, which is nothing but sum over UI is nothing but a sum of n natural number, past n natural number. So it should be n into n plus 1 by 2. So this is nothing but n plus 1 by 2. Similarly, V bar should be n plus 1 by 2. So now SU square, this is 1 by n sum over UI square minus U bar square. UI square, sum over UI square is nothing but a sum of square of n natural number, that means 1 square, 2 square up to n square by U bar square. So this is 1 by n, n into n plus 1 into 2n plus 1 by 6 minus n plus 1 by 2 whole square. So if you simplify this, you get n square minus 1 by 12. Please check. Similarly, is V square, which is 1 by n sum over Vi square minus V bar whole square, which is n square minus 1 by 12. And 1 by n sum over Vi square I from 1 to n, this is equal to 1 by n sum over I from 1 to n di means ui minus di whole square, and we write this as 1 by n I from 1 to n ui minus u bar, because u bar and v bar same, so we write this as ui minus u bar minus vi minus v bar whole square, because u bar minus v bar equal to u bar equal to v bar. So now break this term, we get sum over I from 1 to n ui minus u bar whole square plus 1 by n sum over vi minus v bar whole square minus 2 into 1 by n sum over I from 1 to n ui minus u bar vi minus v bar. Okay, so this is nothing but a su square, this is nothing but sv square, and this is 2 into suv. And su square n square minus 1 by 12, similarly sv square n square minus 1 by 12, so it should be n square minus 1 by 6 minus 2 into suv. So therefore product movement correlation coefficient between u and v, that is the ranks of charge 1 and charge v, nothing but a RUV equal to SUV by root over SU SV, SU square SV square. And one more thing, this implies SUV is n square minus 1 by 12 minus 1 by 2n sum over I from 1 to n di square. Okay, so this is equal to n square minus 1 by 12 minus 1 by 2n sum over I from 1 to n di square by n square minus 1 by 12, because su square and sv square both are same, and these are equal to n square minus 1 by 12. So this is equal to 1 minus 6 by n into n square minus 1 into summation di square I from 1 to 6. 1 to n, sorry. So this is the formula of Spearman rank correlation coefficient. So this is nothing but a R with suffix capital R. Now obviously it should be lies between, since RUV lies between plus 1 to minus 1, this implies this should be lies between minus 1 to plus 1, and equality holds when R in suffix capital R equal to minus 1, when there is a negative perfectly association between two charges, and when it is 1, then it means there is positively perfect association between two charges or two series. Okay, so consider an example. Okay, I consider the problem. Okay. Problem in handwriting were ranked by two judges in a competition. The ranks, the ranking are given below. That is, the individuals denoted by A, B, C, D, E, F, G, H, I, and J. And this is the rank of judge 1. That is, judge 1 with 3 for individual A, 8 for B, 5 for C, 4 for D, 7 for E, 10 for F, 1 for G, 2 for H, 6 for I, 9 for J. Similarly, judge 2 gives 6 for A, 4 for B, 7 for C, and 5 for D, 10 for E, 3 for F, 2 for G, 1 for H, 9 for I, 8 for J. And the difference DI, which is, so this is your U1, this is your U2, this is your U3, U4, U5, U6, U7, U8, U9, U10. And clearly you see that U1 to U10 is nothing but a permutation of past 10 natural numbers. Similarly for judge 2, this is for V1, V2, V3, V4, V5, V6, V7, V8, V9, V10. So DI is nothing but UI minus VI. This means 3 minus 6, this gives minus 3 for D1, this is D1. For D2, this is 4. D3 is minus 2. D4 minus 1, minus 3 for D5, 7 for D6, minus 1 for D7, 1 for D8, minus 3 for D9, 1 for D10. Now according to the formula, so here n is 10. Summation di square I from 1 to 10, this should be minus 3 whole square plus 4 square plus minus 2 whole square minus 1 whole square minus 3 whole square, 7 square plus minus 1 square, 1 square minus 3 whole square plus 1 square, which is equal to 100. Please check. Hence, RUB 1 minus 6, 10 into 10 square minus 1 into 100, which is equal to 0.394. Hence, this value is not so good. So we conclude that there is no close similarity between two sets of ranks. So please tell me, up to that, have you any problem? Please tell me, have you any problem? Have you any doubt? Please ask me question. I will answer. Please tell me, can I rub this portion? Okay, Shashwat, can I rub this portion, Shashwat? Please tell me. Please tell me, can I rub this portion? Okay, thank you. So now consider the second part when tie is occurred. That is case 2. Okay. So case 2, that is the case of tie. Let us consider the case of tie, case of ties, if the same rank that Shashwata, that means it goes to uh, 1, okay? That means similar. If it is close to 0 or I think it is close to -1. This means it is dissimilar, perfectly dissimilar. And close to 1, this means it is close to similarity. But 0.3 is not close to 1, that's why I'm telling it's not close to similarity. Okay, agree? Okay, thank you. Let us consider the case of ties. If same rank is allotted to k individuals, then we have one thing I am telling you, either it is close to 0 in both sides, that means it is not close to similarity, even if you do not say it is close to dissimilarity. If it is close to similarity, that means it's close to 1, and dissimilarity, it means it's close to -1. Okay. Oh. So then is allotted to k individuals, then we have a tie of length k. If this k individuals follow are other individuals in the ranking, then each may be given the rank r+1, but we shall follow the convention that each of the k individual is to given the rank r+1. I want to say that if there is no tie, in that case these ranks are r+1, r+2, r+k, and since there is a tie of length k, this means this should be the average of this rank. So this is equal to r into r+k+1 by 2, which is the average of the ranks that these individuals would have received had there been no tie, no ties. This ties, this tie then does not affect the mean of the ranks. However, it affects the variance. Okay. The sum of the square, because the sum of squares of untied ranks would be r plus 1 whole square, r plus 2 whole square, r plus k whole square, which is equal to, if you break this square, then it should be, I think I write it in that way, r plus I whole square. Okay, I from 1 to k, I from 1 to k, r square 2 I square, which is equal to, since r is independent of I, this means k into r square, 2r summation I from 1 to k I plus summation I from 1 to k I square. So this is equal to k r square 2r summation I from 1 to k I, that means 2r into k plus 1 by 2, this means r into k plus 1. And summation I square I from 1 to k is nothing but a k into k plus 1 to k plus 1 by 6. So when tie is not occur, in that case sum of square should be like that. But when tie is occurred, then the sum of squares of the tied ranks is k into, because all are these k individuals after r have same rank, so this should be k times r plus k plus 1 by 2, because these are the same ranks, so it should be k into r plus k plus 1 by 2 whole square. So we see that because in tied case, so this is the sum of square of the tied ranks, whereas if there is no tie, we get this thing. So this means the variance is affected, but mean is unaffected, because if we look at this, mean means sum over u bar, that is 1 by u bar, which is equal to sum over I from 1 to n 1 by n dy. This means 1 plus 2 plus up to r. Then after that it has k, because just I look at these portions. I think this is enough. See, we give the we use this. So for these portions, other things are same for tied and non-tied. But here you look at this is repeated. This rank is repeated k times. So if you multiply k into this is nothing but a r plus 1, r plus 2 plus r plus k. So this is u bar is nothing but a 1 plus 2 plus r, r plus 1 plus r plus 2, r plus k plus up to n. So this is nothing but a sum of n natural numbers. Hence, u bar is unaffected, mean is unaffected, but variance is affected, because this is the reason. Okay. So, and the difference equal to k r square r k plus 1 plus k into k plus 1 2k plus 1 by 6 minus k into r plus k plus 1 by 2 whole square. So this is equal to k r square plus r k plus 1 plus k into k plus 1 2k plus 1 by 6 minus k into r square k plus 1 whole square by 4 plus r into k plus 1. Okay. And after some simple algebra, we get this. So kq minus k by k. So the difference is this, and consequently the variance is lowered by kq minus k by 12 by n in the case of tie, because this is the difference, and variance is 1 by n sum over ui square by u bar whole square. U bar is fixed. This and the extra things is this portion divided by n because of 1 by n. Okay, so variance is lowered by kq minus k by 12 n in the case of tire drag. Also, it is obvious that the effect of time different sets in it is obvious that the effects of time different sets in additive is additive is additive. Okay, so now suppose that in the ranking with respect to the first character, there are smallest tiles of length k1, k2, ks, and in the ranking with respect to second character, there are small t ties of length k1 dash, k2 dash, k t dash, and the variances should be SU square, which is n square minus 1 by 12 if there is no tie. Since there are s ties for the first character, please listen carefully. For the first character, there are s ties. For the first tie of length k1, we already knew this should be lowered by this term, and this k should be k1. Okay, so it should be minus k1 cube minus k1 by 12 for the first tie. Similarly, there are another tie k2, then this term should be lowered by k2 cube minus k2 by 12, and so on. Hence, it should be n square minus 1 by 12 sum over, I denote this by term tu, where tu equal to sum over I from 1 to s ki cube minus ki by 12. Okay, ki cube minus ki by 12. Similarly, for sv square, which is n square minus 1 by 12 minus tv, where tv equal to sum over j from 1 to, here the length is t, j from 1 to small t, kj dash cube minus kj dash by 12. So the covariance part of u comma v, which is equal to n square minus 1 by 12, we know this thing, n square minus 1 by 12, I think I write this, please recall this. If there is no tie, I write this formula, summation, I just consider this thing. Okay, let me write this first. Sum over I from 1 to n di square, and we see that this is nothing but a dy is sum over I from 1 to n xi minus y bar, where mind it, when there is no time, in that case summation I from 1 to n di square equal to sum over I from 1 to n xi minus yi, or I think I write this thing ui minus vi. Okay, I forgot this thing. So ui minus vi whole square. Okay, so this should be summation I from 1 to n ui square plus summation I from j from I from 1 to n vi square minus 2 into summation ui minus ui into vi. And we see that after adjustment, this is or I think I write this thing in that way. Sorry, write this thing I from 1 to n. Since u bar and v bar same, I think I write this as this vi minus v bar. Okay, whole square, and then we get su square plus v square minus 2 into suv, which gives covariance of u comma v. So covariance u comma v or suv, whatever. Okay, this is and this should be 1 by n. Okay, okay. So of u comma v, if there is no tie, this should be su square, sv square, both are same. So first I write this thing. So from here suv, this is nothing but a su square plus sv square minus 1 by 2n summation I from 1 to n di square. Okay, I think it is better to write 1 by n 2 into suv. Okay, so 2 into suv, 2 into cov uv is nothing but su square plus sv square minus 1 by n sum over I from 1 to n di square. Alright, so this implies cov u comma v, which is equal to n square minus 1 by 12, and for su square this should be n square minus 1 by 12 minus tu when there is a tie. So for su square this should be this, for sv square it should be n square minus 1 by 12 ev. Okay, then minus 1 by n summation I from 1 to n di square, then n square minus 1 by 6 12, here it is cov uv, this is equal to n square minus 1 by 12 minus u plus tv by 2 minus 1 by 2n sum over I from 1 to n di square. Okay, so the formula is R in suffix capital R, which is nothing but a covariance between u comma v by root over su square is v square, and covariance u comma v is this. Okay, and this is equal to n square minus 1 by 12 minus tu plus tv by 2 minus 1 by 2n I from 1 to n di square by su is n square minus 1 by 12 minus tu, and sb square is n square minus 1 by 12 minus tv, where tu and tv we define as u equal to sum over I from 1 to s ki cube minus ki by 12, and tv is j from 1 to t kj dash cube minus kj dash by 12. Okay, so this is the formula for Spearman rank correlation when there is a tie occur. So this is a Spearman rank correlation coefficient in the case of tied rank. Now, for perfect association, agreement or association between the two series of ranks, we shall have ui equal to vi, and hence r in suffix capital R, which is equal to n square minus 1 by 12 by n square minus tu, because if ui equal to vi, this means tu equal to tv and summation di square equal to 0. So we write this n square minus 1 by 12 by tu. Similarly, n square minus 1 by 12 tu equal to n square minus 1 by 12 tv when ui equal to uv. So it should be n square minus 1 by 12 minus tu, hence it is 1. Again, if there is perfect disagreement between the two sets of ranks, we shall have vi equal to ui n minus ui plus 1, and in that case we can easily see that su square equal to is v square, and which is equal to n square minus 1 by 12 minus tu, and also tu equal to tv. Further, summation di square divided by small n, which is equal to n square minus 1 by 3 by 4 tu. Please check. So RR after substitution, we see that which is equal to minus 1. Check this. So now we consider an example. Okay. Suppose two supervisors ranked 12 workers working under them in order of efficiency as follows. So I denote the workers by capital A, B, C, D, E, F, G, H, I, not necessary, Sashodo. This is a very simple thing. So this is not a homework. Okay, I will give you the homework. Okay, either via mail or through WhatsApp by tomorrow. IJKL and supervisor 1. These are the 12 workers. I denote this by A12, and supervisor 1 rank them as follows. 5, 6, 1, 2, 3, 8.5. That means tie occurred. 8.5. 4, 7, 11, 10, 12. We see that F and G, if there is no tie, then it should be 8 and 9. But since these are the same rank, F and G, according to worker supervisor 1, so they get the average rank. That means 8 plus 9 by 2, which is 8.5 and 8. So F get 8.5, G also get 8.5. Now supervisor 2, the rank here also we see that A and B get same rank. That means, or if there is no tie, then A and B should be 5 and 6, or 6 and 5, whatever. But since there is a tie, it should be 5 plus 6 by 2, that is 5.5, 5.5. Okay. 2, 2. 2, 2, 2, 9, 7, 4, 8, 10 and half. 10 and half. So J and L also get same rank, but it is that is 10 plus 11 by 2, and K is a 12. So we see that in supervisor 1 there is a one tie of length 2, there is a single tie of length 2. That is here k1 equal to 2. But here in supervisor 2 there is a 2 tie. One is k1 dash which length is 2. Similarly another tie, that is this, which again of k2 dash which is again length 2. k2 dash is 2, that means length 2. Okay. So according to the formula tu, which is 1 by 12 into 1 by 12 is 1 by n. The formula is, I repeat this formula again, that is 1 by n k1 dash q minus k1, sorry, this should be k1 q minus k1 by 12 because there is a single tie. And since n equal to 12, hence it is 1 by 12 into 2q minus 2 by 12, which is equal to 0.0417. Similarly, TV, there is a 2 ties, that is 1 by n k1 dash q minus k1 dash by 12 plus k2 dash q minus k2 dash by 12, which is equal to 0.25. And di, which is the difference between this, which is equal to minus half, it should be minus half di minus half, minus 1, 0, 1, minus half, 0, that is minus 1, minus half, sorry, this is half, not minus half, this is minus 2, half. So di square, sum over ti square, which is equal to 1 by 4 plus 1 by 4 plus 1 plus 0 plus 1 by 4 plus this is, I think this is 7, this is, oh sorry, this should be 3 by 2, okay, this should be 3 by 2, this is my mistake, please rectify this. 8.5 minus 7 is 3 by 2, okay, so this is 9 by 4 plus 0 plus 1 plus 1 by 4 plus 4, again this is the mistake, it should be 3 by 2, last part, this rectify this thing, 3 by 2, so this is 1 by 4, this is this should be 4, then 9 by 4, and since it is 1 by n summation di square according to the formula, if you look at the formula, then you see that this should be 1 by 2n summation I from 1 to n di square. So summation 1 by n di square, this should be, let's take this value 1.0417. So after substitute this value in the formula of Ru, then we get this value should be 0.956, which is close to 1. This means we can say that the two supervisors are very much similar. Okay, so please take this calculation. Okay, so please tell me, have you any question? So according to, so can you tell me, are you interested to for quiz, or we can, and it or it is better to stop today? And please tell me, please give me your suggestion. Okay, and tell me, have you any queries or questions? Okay, so please tell me, have you any question or queries? শাশ্বত সুমন বাড়ি সায়ক অর্ক প্রভু, please tell me. Anushka, please tell me, have you any queries? Please tell me. Okay, Shashwat. So, are you ready for quiz, or you have a other opinion? Please tell me. I give you simple one problem. I think it's better. Please tell me. Suppose R square. Sorry. Okay, Shayok, I give you simple one question. Okay, please answer me. Suppose R square equal to 0.8 and okay, not 0.8, 0.9, and slope, estimated slope b equal to minus 0.32. Okay, so please tell me, what is smaller? This is the coefficient of determination. The coefficient of determination. So please tell me, what is the value of smaller, and choose the option of scatter diagram. Option A, which is most suitable. Okay, Shayok, please tell me one question. I already did this question. After that, I will stop. Okay, choose the option. First question is, suppose r square is 0.9, b equal to minus 3.2. Find r, value of correlation coefficient, and then choose the appropriate scatter diagram for this problem. Option, which option is correct? Option A, option B, option C. Please tell me quickly. Then I stop. Okay. Please tell me. Please tell me. Sorry, it should be. Sorry, it should be 0.09. Okay, this is my mistake. Please rectify this thing. I think you can easily compute without using calculator. Now you can easily compute. Okay, 0.09. R square equal to 0.09. So please tell me. Value of the coefficient of determination is 0.09. Value of the regression coefficient of y on x is minus 3.2. Then find correlation coefficient between two variables, suppose x and y. Then choose the appropriate scatter plot which is more suitable here. Which is suitable here, not more, which is suitable here. Option A, option B, option C. Please answer. I think it will take hardly 30 seconds, not more than that. Ashwato, please tell me. Shayad, please tell me. Orko Prabhu, where are you? Please tell me what is the answer. Shumon, Onisha, I think Onisha, Unusha, okay. Unusha, tell me. Please tell me. What is the answer? Please tell me quickly. I think it will take hardly 30 seconds, not more than that. It will take more than 1 minute. Okay. Please tell me. Please tell me. What is the answer? And one more thing. So, Shashwata, this is wrong. Shashwata, your answer is wrong. Why, Shashwat? Please tell me. You immediately change. You know the numerical value, but sign you just permutation, use permutation combination, or you have a definite reason. Please tell me. Because your which is your correct answer? 0.3 or minus 0.3? Because you have there are two questions. One is R, another is uh, scatter plot. So please tell me, if R equal to 0.3, why R equal to 0.3? Please tell me the reason. And if R equal to minus 0.3, then also please tell me the reason. Then choose the correct options. Shashwat, please tell me. I think you will take enough time. So please tell me, do you know the answer, or please tell me. So in next class will be on Tuesday at 6 p.m. and I will discuss Kendall Town. Shashwat, okay, Shashwat, first answer is R equal to minus 0.3. It is correct because sine of b is less than 0, should be minus 0.3. And what is the option A, B, C, which is the more suitable scatter plot? Okay, Orko, your answer is also right, but you answer the first part of this question. What is the second part? What is the best, or what is the what is the suitable scatter plot for this question, for this two variable? Tell me. Orko, option C, because it is negatively correlated. Yes, Orko, you are right. Okay, fine. So, thank you. We will meet again on Tuesday at 6 p.m. We will discuss Kendall Town. Thank you. Okay, I know. You are correct. Okay, thank you. So we will again meet on Tuesday at 6 p.m. and we will discuss Kendall Town. And I will send you homework by tomorrow. So WhatsApp. Okay. Thank you.